In this video, we're going to talk about solving a system of two linear equations by the method of substitution and stating whether the system is consistent, inconsistent, or dependent. So before we do any examples, let's look at some definitions. First of all, what is a linear equation? Well, it's an equation in which each term is either a constant or the product of a constant and a single variable raised to the power of 1. So for example, let's say we have y equals 2x plus 3. Let's look at each term. The y term is the same as saying 1 times y raised to the power of 1. So that would be the product of a constant and a single variable raised to the power of 1. Let's look at the 2x term. It's a constant multiplied by a variable raised to the power of 1. And then the last term is just a constant. So that's a linear equation. So what is a system of two linear equations? Well, it's just two linear equations with the same variables. So again, let's say we have y equals 2x plus 3, and then we have a second equation. Let's say we have 2y plus 6x equals 7. Okay, they're both linear equations. They both have the same variables, x and y, so that's a system of two linear equations. So what is the solution to a system of two linear equations? Well, it's an ordered pair that satisfies both equations in the system. Okay, so if you were to graph a linear equation, you would get a line. Okay, so let's draw the Cartesian coordinate system here, Cartesian plane. You have an x-axis and a y-axis. And okay, so there are three different situations with linear equations, right? When you graph the two equations, you get two lines, and the lines could intersect. Okay, so let's say you have an equation, you graph it, and you get a line. Okay, then you take the second linear equation in the system of equations, and you graph it, you get another line. The point where the two lines intersect is the solution to the system, right? So the point has an x coordinate and a y coordinate. That's an ordered pair. If you take that value of x and y and you plug it into both of the equations in the system, then both of the equations would be true. Okay? It's the only point that lies on both lines. If you took any other point, let's say you took a point here, well, that would make the one equation true, but it would not make the other equation true because that point doesn't lie on that line. Okay, so that's the first case, the lines intersect. Okay, the second case is that the lines are parallel. So let's say you have an equation, a linear equation, you graph it and you get a line. Okay, you have a second equation, you graph it, and you get a line which is parallel to the first. Well, for that particular system, there are no solutions, right? Because the lines don't cross anywhere. They don't intersect anywhere. So for that type of situation, we would say that the system, the solution to the system is the null set or the empty set. And that's the symbol we use for the null set. And we would say that that system is inconsistent. Okay, the third situation is if the lines are coinciding. They lie on top of each other. Okay, so let's say again you have an equation, you graph it, you get a line here. Okay, you take the second equation, you graph it, and you get a line that lies directly on top of the first. Okay, those two lines are coinciding. Okay. In that situation, there are an infinite number of solutions. Every point that is on one line is also on the other line. Okay, so for that type of system, we would say that it's dependent. All right, so let's do some examples. In the first situation, we're going to take a look at intersecting lines. Okay, so we have two equations. We have 3x plus y equals 0 and 2x minus y equals 10. All right, your first step is to take one of the equations and solve it for one of the variables. Okay, typically I look for a variable with a coefficient of positive 1. Okay, we have that right here. We have a y term and the coefficient is positive 1. Okay, the coefficient for this term is 3. Coefficient for this term is 2. The coefficient for this term is negative 1. So I look for the term with a coefficient of positive 1, and I'm going to solve for that variable. Okay, so let's take that equation. 3x plus y equals 0. 3x plus y equals 0, and we want to solve for y. Okay, so I subtract 3x from both sides. 3x minus 3x is 0, leaving me with y on the left side. On the right side, I have to subtract 3x. So I get y equals 3x. So my next step is to take this negative 3x and plug it into y for the second equation. So let's write the second equation. We have 2x minus y equals 10. Okay, 2x minus, and wherever we have y, we just plug in this negative 3x because y equals negative 3x. Okay, so let's plug in negative 3x here equals 10. And let's solve for x. Okay, we have 2x. Negative 3x is positive 3x equals 10. 2x plus 3x is 5x equals 10. Divide both sides by 5. These 5's cancel. We have x equals 10 divided by 5, which is 2. Okay, so now we found the x term. The third step is to take that value for x and plug it into either of the original equations. So I'm going to plug it into the first one right here, 3x plus y equals 0, because we've already solved for y. So I can just take this equation, y equals negative 3x, and plug in the x equals 2. So let's do that. Y equals negative 3x. Substitute this 2 in for the x. So I have y equals negative 3 times 2 is negative 6. So now I've got my x and my y value. So my last step is just to write it as an ordered pair. I have x equals 2, y equals negative 6. And that's my solution. Right? If you were to graph it, that would be the point in the plane where the two lines intersect. Okay? And since we have a solution, a single solution, we say that the system is consistent. All right. Let's take another example. Okay, this is an example of parallel lines. So again, the problem tells us to solve the system of linear equations by substitution and state whether the system is consistent or inconsistent. The two equations are y minus 2x equals 4 and 2y equals 4x plus 4. Okay, so step 1 is to solve one of the equations for one of the variables. Okay, again, I'm going to take the first equation and solve for y because the y variable here has a coefficient of positive 1. So let me take that first equation, y minus 2x equals 4, and solve for y. So I want to add 2x to both sides. Negative 2x plus 2x is 0, leaving me with y on the left side. And then I have to add 2x to the right side. So I have y equals 2x plus 4. Step 2, take that value for y, 2x plus 4, and substitute it in for y in the second equation. So let me write the second equation. 2y equals 4x plus 4 to, and here's where I substitute the y equals 2x plus 4. I put 2x plus 4 in for y. So I have 2x plus 4 equals 4x plus 4. And I want to solve for x. So I have to distribute this 2 across here. So I have 2 times 2x is 4x, plus 2 times 4 is 8, equals 4x plus 4. And look what happens here. So I'm trying to solve for x. Well, all I can do is subtract 4x from one side or the other. And when I do that, let's say I subtract it from the left side. I have 4x minus 4x is 0, leaving me with 8 on this side. But then I have 4x minus 4x on this side, which is 0, leaving me with 4. So 8 certainly does not equal 4. So that's a situation where the lines are parallel. There are no solutions. There's no place where the two lines intersect. Okay, so when you get a nonsensical answer, you know that's the situation you have. Okay, and since there are no solutions, we would say that the system of equations is inconsistent. Okay, let's look at the last example. This is where the lines are coinciding. So we have the same problem here. It says to solve the system of linear equations by substitution and state whether the system is consistent or inconsistent. The two equations are y equals 2x plus 5, 2y minus 4x equals 10. Step 1, solve one of the equations for one of the variables. I'm going to take the first one because here we already have y equals 2x plus 5. Okay, so step 1 is done for me here. Step 2 is to take 2x plus 5 and substitute it into y in the second equation. So let me write the second equation. 2y minus 4x equals 10. Substitute 2x plus 5 in for y. 2x plus 5 minus 4x equals 10. I want to solve for x. I have 2 times 2x is 4x, plus 2 times 5 is 10, minus 4x equals 10. Look at this. 4x minus 4x is 0, leaving me with 10 on the left side and 10 on the right side. So that's a true statement. 10 does equal 10, but it really doesn't help me because the variables drop out. So when we have that situation, we know that the two lines are coinciding. They lie on top of one another. So there are an infinite number of solutions. So in that situation, the system is dependent. Okay? I forgot to add dependent to the problem here. And that's it. I hope that helps.